All right, so we're gonna look at engineering notation. So that's different from scientific notation. How? Well, scientists are different from engineers. Engineers are more application, scientists think more abstractly. So, same thing with their notations. With scientific notation, we took a number and we represented it between 1 and 10 and told us how many of a certain place value you had. For example, when we looked at 198, we changed that to 1.98 times 10 to the second power. I have an example written up here. That was because we wanted to say, okay, about how many hundreds do we have? Because that was the highest place value here. All right, that's pretty simple. So this was scientific notation, not engineering notation. So what's the difference between the two? Well, not much. Engineers like to, again, apply things directly, keep it simpler, while scientists like to think of things abstractly. So what engineers decided was, you know what, with the place values, they have groups of three, right? We call those periods. So we have the period with the ones, the hundreds. We have the period with the thousands, right? Because it went thousand, 10,000, 100,000. We have the period with the millions because it goes million, 10 million, 100 millions. Then we have billions and then trillions and so on and so forth. Even going the other direction, we have the same thing. We have tens, hundreds, thousands. Then we go thousands, 10,000, 100,000. So we keep going like that. So with these numbers, they wanted to look at the periods instead of looking at the individual place values when they represented the numbers. So instead of having a number between 1 and 10, they needed a number between 1 and 1,000 because they want all of the exponents here to be in multiples of 3. So 0 as the exponent for the tens would be fine, 3 would be fine, 6, 9, 12. Going the other direction, we would have 0, -3, -6, -9, -12, so on and so forth. So 198, if we were to write that in engineering notation, it would be 198 because that number is already well between 1 and 1,000. Okay, well, that's a bad example then. Let's do something else. Let's do one that we actually see how we convert it. Well, let's look at the number 3,768. So say we want to change that to engineering notation. Well, we go to the highest place value and see what period it's in. It's in the thousands, right? Okay, so it's in the thousands. That means we only want to write down the thousands part. So we're going to have, how many thousands do we have? Well, we have 3.768 thousands, right? Well, thousands would be 10 to the third. But wait, that's the same as what we just did, isn't it? That's still scientific notation. Well, this is written in scientific and engineering notation. How do I know that? Because this is a scientific notation because this number is between 1 and 10. We got 3.768. And I know this is an engineering notation because this number is between 1 and 1,000. And this exponent is a multiple of 3 because it is 3. Okay, that was simple. I still don't quite believe you because that still is just scientific notation to me. Come up with something else. All right, let's come up with another example. Let's say we had the number 0.00576. Let's say we have this. Okay, so we have 0.000576. All right. So let's see what period we're at. Well, that was our first period because that would stop at the hundreds. Then this would be at the thousands. This would be 10,000. Okay. So we're going to have 5, 7, and 6. Well, how far did we go? Well, we went from here, moved the decimal 1, 2, 3, 4, 5, 6 places. Well, how did I know to get 576? Well, because we had thousands, 10,000s, 100,000s, and then millions. So that's our highest place value, was millions. So that grouping would have been 576. And our exponent here would go to -6. All right, simple enough. That was our first period. And then there's our second one. The highest whereas in millions. So we must have 576. That number is between 1 and 1,000. Our exponent is a multiple of 3 because it's negative 6. Right? Now, sometimes for people when they're doing engineering notation, what they would do is move the decimal over. So let's give a different example so you can kind of see what I'm talking about. Let's do 0.0, let's do 7357. So they would move the decimal over 1, 2 places to start. So first they move it and do a scientific notation. So 1, 2. And so they would get 7.357. And this would be times 10 to the power. We moved it twice, so it would be negative 2. And they say, okay, well, that is not a multiple of 3. So it must be wrong then. That's true, it would be. So how do I change this to be a multiple of 3? Well, if I just go over one more time, I would have gone over 3 times, right? So they would go in, they erase this, and they move this decimal over one more time. That's it. So if you think of it as, let me just get my exponent on a 10 to be a multiple of 3, that's another way to do engineering notation, especially if you get the scientific notation down. If you understand that, which most people it's easier to do. Okay. So that's one thing that people can do. Another thing that people do for engineering notation so I'll do the number 1, 7, 3, 5, 6.43. Okay, so 17,356.43. All right, very simple number. So sometimes what people do is they group things in terms of 3. So I move this over one time until the remaining is going to be a number between 1 and 1,000. Remember, that's what you needed for the number for engineering notation. So to move this decimal over by groups of 3, I only have to do it over between the 7 and 3, and I'll get 17. All right, so 17.35643, and I only moved it over by one group of 3, so this would be 10 to the third. How do I know that? Because I'm in the thousands place there, right? All right. So that's the difference between engineering notation and scientific notation. Engineering notation, again, has an exponent on the 10, that's the power of 3. These numbers are between 1 and 1,000. For scientific notation, our numbers are between 1 and 10, and the exponent can be anything on 10. So that's the difference. Sometimes, like we saw in one of our examples, it will be in both scientific and engineering notation. That can happen, and that's okay. But if you ever have to convert between the two, just remember that engineering notation, the exponent has to have a multiple of 3. And that is it. I'll see you soon.